Evaluate sine of negative pi over 6, cosecant of negative pi over 3, and tangent of negative 2 pi over 3. All of these inputs are negative. Using the even and odd property, we know that sine is an odd function, so sine of a negative input is the negative sine of the same number but positive. And using our first quadrant with the special number from the unit circle, the point that associates with t equals pi over 6 is root 3 over 2 comma 1/2. But sine is the y-coordinate, and so the negative sine of pi over 6 is 1/2. And we are done. Similarly, with cosecant, we would rewrite this as the reciprocal of sine, 1 over sine of negative pi over 3. And sine is an odd function, so sine of negative pi over 3 is negative of sine of pi over 3. Using the special number on the unit circle, the terminal points that associate or determined by pi over 3 is x equals 1/2, y equals root 3 over 2. Sine of pi over 3 is therefore root 3 over 2. And so this is 1 over negative sine of pi over 3 is root 3 over 2. We will need to simplify this number. This is a negative number because 1 divided by a negative, so it is negative. And 1 over is the reciprocal. The reciprocal of root 3 over 2 is 2 over root 3. We then rationalize this denominator by multiplying root 3 over 3 to get negative 2 root 3 over 3. And we are done. For tangent of negative 2 pi over 3, which is an odd function, and so tangent of negative 2 pi over 3 is negative of tangent of 2 pi over 3. 2 pi over 3 is in the second quadrant, and the coordinate of the terminal point that is determined by t equal 2 pi over 3 in the second quadrant, x is negative and y is positive. Remember that in the third quadrant, with t equals pi over 3, the terminal point is x equals 1/2, y equals root 3 over 2. And so in the second quadrant, this point has the coordinate x equals negative 1/2, y is root 3 over 2. It would be much quicker if we didn't have to do that, which is if we remember this diagram for the special numbers from the first quadrant. But it is okay if we have to determine the coordinate of the terminal point again. We now have the coordinate of the terminal points that is determined by t equal 2 pi over 3. The negative in the front, we rewrite it. Tangent of 2 pi over 3 is defined to be the y-coordinate, which is root 3 over 2, over the x-coordinate, which is negative 1 over 2. The 2 and the 2 canceled out, so we end up with the root 3, and the negative divided by the negative is a positive number, so the answer is root 3. Remember that we're not looking for the terminal point in the second quadrant. We did that after we rewrite the tangent of negative 2 pi over 3. If we were to find it directly, we would need to go to t equals negative 2 pi over 3 from the point 1, 0, clockwise. Negative pi over 3, negative 2 pi over 3. which is in the third quadrant where x is negative and y is negative, the coordinate of the terminal point that is determined by negative 2 pi over 3 is negative 1/2 negative root 3 over 2. If we were to determine tangent of negative 2 pi over 3 directly without having to use odd or even properties of the function, then at the terminal point determined by negative 2 pi over 3, the y coordinate is negative root 3 over 2 and the x coordinate is negative 1/2. So the answer is still root 3.